And good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today, after we answer any questions you might have from section 14.2, we're going to go on and finish up the material that will be covered on this next test. We're going to look at section 14.3. Please make note that your homework over the weekend not only includes 14.3, but also a test review set of material in WebAssign. Then Monday, we will meet and have review for the test. Tuesday, there will be no Zoom meeting. Tuesday, basically, you'll take the test. I mean, you can take the test anytime from now till then, but it has to be completed by Tuesday at 11:59. Keep in mind, you have 75 minutes. So once you open that test, you've got 75 minutes to complete it. So make sure that you're going to have time where you won't be disturbed, etc., etc. And again, you can show up Tuesday for a Zoom meeting, but I won't be here. Okay. So with that, are there any questions from section 14.2 before we go on? I'll take that as a no. All right, so 14.2 was arithmetic sequences, where we had a starting term and then a common difference that we added to get the next term, and then we added that common difference to get the next term, etc., etc. Today we're going to look at geometric sequences. So geometric sequences. In this situation, instead of having what is called a common difference between the terms, we have what is called a common ratio. And the way that works is we've got the first term in the sequence. If we take the first term times a multiplier, if you will, but the authors call it a common ratio, so we use R, that gives us the next term. If we take that term times the common ratio, we get the next term, etc., etc. So what our formula ends up looking like is this: a sub n equals a sub 1 times r to the n minus 1 power. So that n minus 1 right here is the exponent on the common ratio. Now, I mentioned yesterday that the arithmetic formula, or sequence formula rather, that you could have that formula on a piece of paper for your test. You can also have this formula. Those are the only two things that you should have in front of you when you're taking the test, other than paper and pencil and a calculator if you need one. All right, so now let's take a look at problems involving the geometric sequence. Okay. So here's a problem that says, write the first 5 terms of a geometric sequence with the given properties and then find the specified term. So very much like the problems we did yesterday with the arithmetic sequence, only now it's a geometric sequence. It says that the first term is 3 and the common ratio is 2. And then it says find the 9th term. Okay, now the directions said to find the first 5 terms. So we know a sub 1 is 3. We need to find a sub 2, a sub 3, a sub 4, a sub 5, and then finally a sub 9. So to get from a sub 1 to a sub 2, I take a sub 1 times the common ratio. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. Now, I could find a sub 6, a sub 7, a sub 8, a sub 9 by continuing to multiply each previous term by 2. But what if I asked you for a sub 412? You wouldn't want to do it that way, and I could. So let's look at how we can find a sub 9 without having to just get there one term at a time. All right. Again, our formula is a sub n equals a sub 1 times r to the n minus 1 power. So a sub 9 is a sub 1, which is 3, times r, which is 2, raised to the n minus 1 power. In this case, n is 9. So this becomes 9 minus 1. So we've got 3 times 2 to the 8th power. Careful, order of operations, we would do the exponent before the multiplication. So don't take 3 times 2 and get 6 and take 6 to the 8th power. We take 2 to the 8th power times 3. Okay, well, let's see. What is 2 to the 8th power? I'm going to punch that into my calculator. 2 raised to the 8th power is 256. That times 3 is 768. So the 9th term in this geometric sequence would be 768. Any questions about this example before we go on? All right, let's take a look at another example. It says the first term, well, same directions as before, find the first 5 terms with the given properties and then find the specified term. We're told that the first term is -5. The common ratio is 1/5, and we are to find the 8th term. Okay, so this one's going to get a little tricky with that fraction. So we know a sub 1, we need a sub 2, a sub 3, a sub 4, a sub 5, and then finally we're going to find a sub 8. So I take a term in the sequence times the common ratio to get the next term in the sequence. -5 times 1/5. -5 times 1/5 would be what? -1. Okay. -1 times 1/5 would be -1/5. -1/5 times 1/5 would be -1/25. And -1/25 times 1/5 would be -1/125. Okay, so there is the first 5 terms. Any questions before we go on to find a sub 8? All right, so using the formula, a sub n equals a sub 1 times r to the n minus 1 power. A sub 8 would be a sub 1, which is -5, times r, which is 1/5, to the n minus 1, or in this case, 8 minus 1 power, which would be -5 times 1/5 to the 7th power. Now, here's where things get a little bit tricky. If I take 1/5 and raise it to the 7th power, my calculator gives me 1.28 times 10 to the -5th power. But I don't want a decimal answer. I want a fraction answer. So here's what I'm going to have to do. Okay. This is -5 times. Recall, if you have a fraction raised to a power, you raise the numerator to the same power and the denominator to the same power. So the quantity 1/5 to the 7th power would be equal to 1 to the 7th power over 5 to the 7th power. You still with me? Anybody lost? Okay.
I'm just writing all this down.
Okay. All right. I can wait.
No, I'm good. I've got it.
Now, 1 to the 7th power is just 1. I'm going to leave 5 to the 7th power there for a moment. I could reduce this. I could take a 5 out of the numerator and make this a -1, and a 5 out of the denominator and make it 5 to the 6th power. You see how I did that? So now I've got -1 over 5 to the 6th power. Now if I go in onto my calculator, 5 to the 6th power, and I get 15,625. And there's your final answer in fraction form. So I had to separate the numerator and the denominator and raise them to powers separately to get the form that I wanted easily. So a sub 8 is -1 over 15,625. Any questions there? Okay. Moving on, next example. Find the specified term of the geometric sequence with the following properties. The first 3 terms are 2, 6, 18. So a sub 1 is 2, a sub 2 is 6, a sub 3 is 18. Find the 7th term. So find a sub 7. Now, let's go back in time for a minute to yesterday when we had an arithmetic sequence, and to get from one term to the next, we added the common difference, okay? So if we knew a term and the next term, we could take the higher term minus the lower term and come up with a common difference, okay? Same thing here. If we know that a sub 2 is 6 and a sub 1 is 2, well, 2 times what is 6? 2 times r is 6. So 6 divided by 2 would give you r. So what is r? What's 6 divided by 2?
3.
Likewise, what's 18 divided by 6?
3 again.
3 again, right. So to find the common ratio, you take a term in the sequence divided by the previous term, okay? In an arithmetic sequence, to find the common difference, you subtract. In the geometric sequence, to find the common ratio, you divide. All right. So now, using the formula, a sub n equals a sub 1 times r to the n minus 1 power. Okay. We know we're looking for a sub 7. Oh, wait a minute. Were we supposed to find... that's right. It didn't ask us to find the first 5. It just gave us the first 3. Just wanted to make sure there. Okay. So a sub 7 would be a sub 1, which is 2, times r, which is 3, to the n minus 1 power, which would be 7 minus 1 power. So we've got 2 times 3 to the 6th power, which is 2 times, let's see here, 3 to the 6th power is 729. That times 2 is 1458. So the 7th term in this geometric sequence is 1458. Any questions there? Okay. Let's see here. I think we've got time for another one of those. The first 3 terms r 1/2 -5/2 and 25/2. Find the sixth term. Now, again, this author tends to use fractions, improper fractions, proper fractions, rather than mixed numbers or decimals. I believe that in WebAssign you can put in decimals as long as it is the exact answer. But if you have a fraction that ends up being some big, long, repeating decimal, don't round it off. It won't be counted correctly. So fractions are probably the safest way to go. Okay. So if I'm going to use this formula, what piece of information do I need to find next?
The number that every term is multiplied by.
Right, which is the common ratio. And we use, so, right, in R. So how are we going to find R?
Divide the second term by the first, perhaps?
Okay, not even perhaps, exactly, yes. Okay, so if we take -5/2 divided by 1/2, that is equal to -5/2 times, dividing by a fraction is like multiplying by its reciprocal, okay? So I'm getting -5. Well, just to make sure, tell you what, let's take a⁻³ and divide it by a⁻². Let's see what that, if that gives us the same answer. That would be 25/2 times -2/5, which would give us -5. Okay, so R is -5. All right. So now, using this formula, a⁻⁶ is a⁻1 times R, which is -5 to the 6 - 1 power. So a⁻⁶ is 1/2 times -5 to the 5th power. So a⁻⁶ is 1/2 times, let's see. Now, -5, so I'm going to go parentheses, -5, close it up, to the 5th power is -3125. Okay. So a⁻⁶ is going to be -3125/2. And I can't reduce that. I could change it to a mixed number or a decimal, but I'm going to just leave it in reduced fraction form. So there is our answer. So the numbers were a little more tricky in this problem, but the same process. Any questions before we go on? Okay. This says, write the first 5 terms of the geometric sequence with the following property. It says the first term is 2. It says R is greater than 0. And it says the third term is 18. Now, we're supposed to write the first 5 terms. They give us the first term and a third term, so we've got to find a⁻², a⁻⁴, and a⁻⁵. Okay. All they tell us about R is that R is positive. Okay, well, let's see here. a⁻n equals a⁻1 times r to the n-1 power. That's the general formula for the geometric sequence. Okay. So a⁻³ would be equal to a⁻1 times r to the 3-1 power. Okay, because n is 3. So a⁻³ is equal to 2 times r squared. But I also know that a sub 3 equals 18. So just like yesterday, we've got two different ways of describing a certain term, in this case, a sub 3. So if a sub 3 equals 2r squared, but a sub 3 also equals 18, that means that 2r squared equals 18. Right. Any questions before we go on with this problem? So now I need to find r. Well, first of all, let's find r squared. If I divide both sides by 2, I get r squared equals 9. Now, we're going to do a little bit of dealing with taking roots, square roots or cube roots or whatever. Later on in the course, we'll have a whole chapter involving it, but right now, just a little taste of it. Consider this. What is 3 squared? Come on, this isn't rocket science now. What's 3 squared?
9, right?
9, good. What's negative 3, the quantity squared?
I want to say that would be 9 as well.
And you are correct. You have spoken well, young Padawan. All right. Now, so that means if we take the square root of 9, we're going to get positive or negative 3. So in fact, the notation looks like this. We say we take the square root of both sides and we put this plus or minus outside. The point being that if r squared equals 9, r could equal negative 3 or r could equal 3. Okay, now that's why this information was given. They said r is positive, therefore in this case we're going to use r equals 3. If it had said r was less than 0, we would have chosen the r equals negative 3 value. Okay, so now that I know that r is 3, what's 2 times 3?
That would be 6.
6 times 3.
18.
18 times 3. That's
that
right.
one didn't come as instantly.
That's right. If you wait long enough, I'll just do it for you. Okay. 54 times 3.
162, is it?
Correct. And there you have it. Okay. So there's this little ditty here that's kind of a new idea. Not totally new, but anyway. We okay with this? Let's do another one. It says the first term is 2. And now we're going to say r is less than 0. And it says write the first 5 terms. So we've got to find the rest of them. They also tell us the third term is 50. Okay. So in this case, the common ratio is going to be a negative number. Using the formula a sub n equals a sub 1 times r to the n minus 1 power. We're going to take a sub 3, which is equal to 2 times r to the 3 minus 1 power, which is equal to 2r squared. So a sub 3 equals 2r squared, but a sub 3 also equals 50, which means that 2r squared equals 50. This looks an awful lot like the last problem. Divide both sides by 2 and r squared equals 25. Well, what times itself? In other words, what is the square root of 25?
5.
Or it could, oops, hang on here. Or it could be negative 5, okay? So r equals 5 or r equals negative 5. But in this case, we're going to use the negative value, okay? So what's 2 times negative 5? Come on, this is Friday, not Monday. Or is it like Monday we're still waking up and Friday we've got 1 foot in bed and 1 foot here, and so we're just kind of in a fog, you know, we're already looking forward to sleeping.
Sorry, I was just writing stuff down. So
Okay,
you said 2
times negative
multiplied by
5.
negative 5?
Yeah, what's that?
10.
It's what?
Negative 10.
Negative 10. Okay, sorry, I'll quit picking on you so much. What's negative 10 times negative 5?
That would be 50.
Good. What's 50 times negative 5?
250? Negative 250.
Okay. And what's negative 250 times negative 5? 1250. Okay. So there's our first 5 terms. Any questions about that? Okay. Now, yesterday we had arithmetic means that we put between 2 end values. We had like 1 or 2 or 3 or 4 arithmetic means in there. Now we're going to do problems with geometric means. We good to go on to the next problem?
Yeah.
Okay. It says, find the geometric means to be inserted in each geometric sequence. It says, insert 3 positive geometric means between 2 and 162. Okay, so the first term is 2. We're going to insert 3 positive geometric means. So that means a sub 2, a sub 3, and a sub 4. And then the last term is 162. Okay. And again, keep in mind that R is positive because they said so. So we're going to use the formula a sub n equals a sub 1 times R to the n minus 1 power. So a sub 5 is a sub 1, which is 2, times R to the 5 minus 1 power, which is 2 times R to the 4th. So a to the 5th equals 2 times R to the 4th. But a to the 5th also equals 162, which means that 2R to the 4th equals 162. Okay. Any questions yet? What's the next step going to be?
Divide both sides by 2.
Absolutely. Good job. So R to the 4th equals 81. Okay, now we can take the 4th root. Whenever we take an even root of both sides of an equation like this, we're going to get both a positive and a negative number. Okay, so let's think about this. Something times itself, times itself, times itself is 81. What's 1 times 1 times 1 times 1? Well, that's just 1. What's 2 times 2? That's 4. Times 2 is 8. Times 2 is 16. What about 3 times 3? That's 9. Times 3 is 27. Times 3 is 81. Oh, so R would be plus or minus 3 because 3 to the 4th power is 81. Negative 3, the quantity to the 4th power, is also 81, right? So 3 to the 4th equals 81. Negative 3 to the 4th equals 81. But we're supposed to choose a positive R value, so we're going to use positive 3. Okay? What's 2 times 3?
6.
6 times 3.
18.
18 times 3.
54, you said, I think?
54 times 3. Is it 162?
Yes, I believe so.
Yes.
Yeah, in fact, I think we had these same numbers in a previous problem. Apparently the author's not too creative or whatever. Maybe they're just lazy like me. I work harder at being lazy than anybody I know. All right. Let's see here. How are we doing? We've got plenty of time for me to torture you with another one or two. Let's see. We're going to insert 4 geometric means between -4 and -12,500. So 4 of them. So a sub 2, a sub 3, a sub 4, a sub 5. So the last term that they give us would actually be a sub 6. Okay, we got our first term -4, our last term -12,500, 4 in the middle, so a total of 6. Okay,
This is going to be a doozy.
we'll see. We'll see. Now, where did this go? Let's see here. Geometric means between. I'm just looking to see. They didn't say anything about whether it was positive or negative. So let's see what happens. Okay. A sub n equals a sub 1 times r to the n minus 1 power. A sub 6 equals -4 times r to the 6 minus 1 power. A sub 6 equals -4 times r to the 5th power. Now I know why they didn't tell us whether it was positive or negative, and we'll talk about that here in a minute. But a sub 6 also equals -12,500. So a sub 6 equals that. It also equals that, which means -4 r to the 5th equals -12,500. Our next step, we're going to divide both sides by -4. So we get r to the 5th equals, let's see, if we, well, negative divided by negative, excuse me, is going to be positive. 12,500 divided by 4 is 3,125. All right. When you take a square root or a 4th root or a 6th root, in other words, an even root of both sides of an equation, you have the possibility of a positive and a negative solution, that plus or minus. But when you're taking an odd root, you're only going to get one solution. And you can take an odd root of a positive number, you get a positive answer. You can take an odd root of a negative number, and you get a negative answer. So in this case, the 5th root of r to the 5th, r is going to equal the 5th root of 3,125. Okay, now, up to now, and I think I'm still going to do this, I haven't really gone into how can we do this on our calculator. This one really isn't that bad. It may seem like it is, but consider this. What number do you multiply by itself that ends in 5? In other words, the product ends in 5. What's a number times a number that ends in a 5?
Well, 5.
Yeah, 5 times 5 is 25. Okay. What number, when you take it times itself, still ends in 5? What's 5 times 5 times 5? Well, that's 125. What's 5 times 5 times 5 times 5? That's 625. Anyway, what do you think r is going to be? What would you suspect?
At this rate, I'd say a 5.
Well, let's find out. What's 5 to the 5th power? Oh, it's 3,125. So the 5th root of 3,125 is just 5. And I know this is kind of on a need to know basis. I'm just giving you a little bit of information about these radicals, these roots. We'll spend a whole chapter on it down the road, but this is enough to get you by in this situation. So what's -4 times 5? That's -20. What's negative 20 times 5? That's negative 100. What's negative 100 times 5? That's negative 500. What's negative 500 times 5? That's negative 2,500. And what's negative 2,500 times 5? That's negative 12,500. So let's see, what were we supposed to do? We were supposed to get the first, well, actually, we were supposed to find the 4 that go in the middle. Okay. All right, let's see here. Any questions before we go on? And I'm not going to give you some, huge number like find the 17th root of 12,082,000. That's not going to happen. So if you're worried about that, we'll save that for chapter 9. Okay. All right. This says insert 3 geometric means, 2 positive and 1 negative, between negative 64 and negative 1,024. So we've got 3 geometric means between negative 64 and negative 1,024. Okay, but it says that 2 of these means are, let's see, yeah, 2 of them are going to be positive and 1 of them is going to be negative. So the numbers here, not the common ratio, that's going to be some fixed number, but these numbers in here, 2 of them are going to be positive and 1 of them is going to be negative. Let's see now. A sub n equals a sub 1 r to the n minus 1 power. A sub 5 equals a sub 1, which is negative 64 times r to the 5 minus 1 power. A sub 5 equals negative 64 r to the 4th. Okay. But we also know that a sub 5 equals negative 1,024. So a sub 5 equals that, a sub 5 equals that. Our equation is negative 64 r to the 4th equals negative 1,024. So now we're gonna get r to the 4th by itself. We'll divide both sides by negative 64. And let's see here. Negative divided by negative is positive. 1,024 divided by 64 is 16. Okay. So now we're going to take the 4th root of both sides. Remember, I said if you're taking an even root, you're going to get both the positive and the negative possibilities. So r equals plus or minus. Okay, so what times itself times itself times itself is 16? Well, 1 times 1 is 1 times 1 is 1 times 1 is 1. So it's not 1. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Oh, so the 4th root of 16 is 2. So r is going to be plus 2 or r is going to be minus 2. So r is either going to be a positive 2 or r is going to be a negative 2. Well, let's go back to what they said in the instructions. They said we're supposed to find 3 geometric means. And let's see here. What did it say? 2 positive and 1 negative. So these 3 numbers over here, 2 of them have to be positive and 1 of them has to be negative. All right. Consider this.
Sounds like we
Go ahead.
Negative 2. Right?
Yeah, you're correct. Let's look at what if we used positive 2? Negative 64 times positive 2 would be negative 128, times positive 2 would be negative 512, times positive 2 would be negative, negative, negative. Right, so it can't be the positive 2, because then we just have all negative means. But if we use a negative 2, they're going to alternate positive, negative, positive, negative. Negative 64 times negative 2 is positive 128. Positive 128 times negative 2 is negative 256. Negative 256 times negative 2 is positive 512. positive 512 times negative 2 is negative 1024. And we have 2 positive and 1 negative means. So good job, Abel.
Thank you.
That's why your name is Abel, because you're very able, right? I'm sure that no one's ever said that to you.
In certain situations.
Yes. And no one has ever called me mayonnaise. I've never heard that. Never, never. It's always amusing to me when an adult will make some comment like they think that they're the first person that's ever thought of that. Ah, well, all right. Aren't we interesting creatures? Let's see here. What do we got? We got 9 minutes. Let's do one more just for fun. It says, find the geometric mean between 2 and 128. So a sub 1 is 2. We're going to find one geometric mean, and a sub 3 is 128. Okay. So once again, a sub n equals a sub 1 times r to the n minus 1 power. A sub 3 is a sub 1, which is 2, times r to the 3 minus 1 power, which is 2r squared. So a sub 3 is 2r squared. And a sub 3 is also 128. So 2r squared equals 128. Divide both sides by 2. R squared equals, what, 64. The square root of r squared would be plus or minus the square root of 64. So r is going to be plus or minus. What times itself is 64?
I want to say 8.
Then do. So 8 times 8 is 64. Negative 8 times negative 8 is 64. Now, here's the problem. In some of the other questions, they told us specifically r was positive or r was negative. The means were positive, the means were negative, 2 of one of the other. They don't give us any hints here. So we have to actually consider both possibilities. If we take r equals 8, we get 16, and then 16 times 8 is 128. But if we take r as negative 8, we get negative 16. And then negative 16 times negative 8 would still be 128. So in fact, we get 2 possible answers for that geometric mean. Okay, negative 16 or negative 16. Okay, so just a reminder, this is Friday, in case you've forgotten. The homework over the weekend is 14.3, and then the review questions in WebAssign. Okay, those are both due Monday night. By the, absolutely, no later than that. On Monday, we will review, so there won't be any new material on Monday. I'll just go through and answer questions from 14.3, as well as anything from the review that you want to discuss. And then I'll turn you loose on Monday. We won't meet Tuesday. There won't be a Zoom meeting. I mean, there will be, it's just on the calendar, but no, I'm not going to show up. Okay, so don't sit there waiting for me for an hour. You'll take your test on Tuesday, okay? And then Wednesday, we'll go back to heading on to the next chapter of information. So let me stop the recording.